Equations of parallel and perpendicular lines. This section should be a lot of algebra review for you. It shouldn't be entirely new. Some of it may just be, you may just need to review it, refresh your memory on how it works. But for the most part, this should be things that you already recognize. I am going to, in this lesson, use a specific type of equation for a line that you may not have been previously introduced to. So that may be a little bit new for you. I prefer this type of equation, but there are other ways that it can be done. And if you think you have a different way that you can do it other than what I show here, please let me know. I'll look over it and let you know if it's okay to use that method or whether you've got mistakes in it that you want to avoid. All right, so back to where we were headed. Equations of parallel and perpendicular lines. The slopes of parallel lines are equal, or some people might say the same, which is fine. The parallel lines have the same slope. The symbol for parallel lines is two lowercase l's side by side, just like the two lowercase l's in the word parallel. The slopes of perpendicular lines are opposite reciprocals. So we've got two factors then to take care of here. Opposite, meaning one of them will be positive, the other slope will be negative, and reciprocals. And we know what a reciprocal is for a fraction. So an example of opposite reciprocals would be 2/3 and -3/2. One of them is positive, the other is negative, and they're reciprocals of one another. The symbol for perpendicular, it's an upside down capital T. It's got right angles present. These next three questions should be review from algebra. Identify the slope of the line y equals 3x minus 7. Remember, slope is the value in the equation that precedes the x, right in front of the x. That's the slope. So here the slope is 3. What is the slope of a line parallel to y equals negative 2x plus 9? Okay, so parallel, remember, parallel lines have the same slope. So a parallel line will have to have the same slope as this equation, -2. And the last one, what is the slope of a line perpendicular to the line y equals -3/5 x plus 8? So here again, we're looking for a slope. To be perpendicular, we need to have an opposite reciprocal slope. So since this slope is negative, we know our slope will be positive. Since that one's 3/5, I want the reciprocal 5/3. So we have slopes in general, slopes of in equations that are already solved for y. Keep in mind that we're only talking about the slope if it's in y equals mx plus b form. All right, so moving on down here. We've got three formulas that we're going to be looking at here. One of them is the slope formula, which allows us to find the slope of a line or a segment between 2 points. And that is m equals y sub 2 minus y sub 1, all divided by x sub 2 minus x sub 1. Keep in mind that x1, y1, and x2, y2 are 2 points on a coordinate plane, and you're using those values to find the slope between them. The slope-intercept form of a line, y equals mx plus b. Just review here, m is the slope of that line, and b is what we refer to as the y-intercept. It's the value of y at which the graph would cross the y-axis. You're most familiar with those two equations. Those two formulas are going to give you everything that, or most of what you did in Algebra 1. Today I'm going to be using this third one called the point-slope form of a line. Our answer will still end up, we're going to start with point-slope form on our problems, but our answer will still be in slope-intercept form whenever we've completed the problem. So the point-slope form, y minus y sub 1 equals m times the quantity x minus x sub 1. In this case, m is still the slope, and x sub 1, y sub 1 is a point on the line. And knowing those two values will allow us to find the equation of the line itself. Okay, so we have 5 examples we're going to be working through today. 1, write the equation of a line parallel to the line y equals 5/6 x plus 2, passing through the point negative 12, 10. Okay, so a couple of things to mention here. Parallel to this line, that's going to tell us something about slope. And it has to pass through the point negative 12, 10. So that's going to give us something for our point on the line. Alright, so using our slope, to be parallel to this line, it has to have the same slope. We see the slope in this line being 5/6, the value right in front of the x. So the slope of our line will also have to be 5/6. The point we're given represents our x1, y1 values. X is always listed first, remember. Once you have those values determined, you have your slope and you have your point that's on the line, then you're ready to actually start substituting into the formula. So we go to our point slope form. I'll start by writing the equation down without values substituted in. Remember that the y sub 1 and x sub 1, those should be subscripts, not exponents. We have 3 values now that we can substitute in. We have our slope of 5/6 and we have our x1, y1 values. So here the x and the y, the ones without the subscripts, stay where they are. So this becomes y minus y sub 1, which was 10, equals m, which is our 5/6, times the quantity x minus x sub 1. Now we have to be very careful. Remember this minus negative 12, we usually write as a plus 12. Once you have your values substituted in, you have 2 steps left. Step 1, distribute that slope on the right side of the equation. So distributing means we're going to leave the left side alone, multiply everything in that set of parentheses by 5/6. So we have 5/6 x plus 5/6 times 12 gives me 10. So step 1, distribute. Step 2, solve for y. So in this case, to solve for y, we want to get this minus 10 to go away. We're going to add 10 to both sides. So we get 5/6 x plus 20. Notice that is in slope-intercept form. The slope of the line is 5/6. The intercept would be 20. So we start in point-slope form, but in the end up in slope-intercept form. Okay, moving on to number 2. Write the equation of a line perpendicular to the line y equals 9x minus 1. Perpendicular to that line. Passing through the point negative 3, 4. Okay, so 2 things to take care of. Our point is our x sub 1, y sub 1. And here we have to determine the slope. We're told it's perpendicular to this line. Now I can see this line has a slope of 9. So I need, for my equation, a slope that is the opposite reciprocal of negative 9. Or of positive 9, I'm sorry. The opposite reciprocal of positive 9. So the opposite of that positive will make this negative. The reciprocal of 9 becomes 1/9. So negative 1/9 becomes our slope that we're going to be using. Okay, write the equation. So y minus y sub 1 equals m times the quantity x minus x sub 1. Substitute in your 3 values. Y minus y sub 1 is 4 equals, substitute in your m of negative 1/9. X minus x sub 1 is negative 3, so minus a negative, there's our plus again. It won't always do that, it just happens to on these 2 problems. And now we're ready for our 2 steps. Distribute, solve for y. So we're going to distribute first. Y minus 4 equals. Distributing here, we get negative 1/9 x. The negative times the positive is going to make this a minus, and 1/9 of 3 is 1/3. Get y by itself by adding 4 to both sides. Now, if you have a struggle with fractions, it is okay to use a calculator. But when we add 4 on both sides, we should end up with y equals negative 1/9 x plus 11/3. Right, on to the back. 3 more problems that we're going to be dealing with slopes and parallel and perpendicular lines. Write the equation of a line, there is a typo there that should say of a line, passing through the point 25 that has a slope of 3/10. Okay, I want you to pause the video at this point and work this one out on your own. And then when you're finished, come back and see how you did. Alright, so we've got our point 25, so it's going to be our x sub 1, y sub 1, and our slope of 3/10. Start with the equation of a line. Substitute in the values. Distribute. And lastly, add 5 to both sides. So y equals 3/10 x minus 1. Number 4, line R passes through the point -2, 2 and the point 5, 8. Line S passes through the points -8, 7 and -2, 0. Is line R perpendicular to line S? Now remember, to determine if they are perpendicular, remember that's what this little symbol means. If they are perpendicular, then their slopes should be opposite reciprocals. Slopes should be opposite reciprocals, which means I need to know the slope of line R and I need to know the slope of line S. And you have 2 ways that you can do that. You can graph the 2 points for line R and then count rise over run and determine the slope of line R. Plot the 2 points for S, count rise over run to find the slope of line S. Or you can use the slope formula, which is what we're going to be doing here. So our slope formula, remember that's on the front side of the page. We've already written that down. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So for line R, I'm going to let my first point be my sub 1's, x sub 1, y sub 1, and the second point be the sub 2's, x sub 2 and y sub 2. So substituting in our values, again, M equals y sub 2 minus y sub 1, 8 minus 2. In the denominator, x sub 2 minus x sub 1, so 5 minus -2. Remember that minus negative makes it plus. So in this case, the slope of line R becomes 6/7. And this is for R. Now we'll do the same thing for S. Slope equals. Now we're letting this first point here be x sub 1, y sub 1, and the second point x sub 2, y sub 2. So y sub 2 minus y sub 1. 0 minus 7 over x sub 2 minus x sub 1. -2 minus -8. -2 minus negative becomes a plus 8. Okay, so the slope of line S then, 0 minus 7 is -7. -2 plus 8 is 6. So the question becomes, are they perpendicular? Are they opposite reciprocals? And I can see they are opposites. One is positive, one is negative. And they are reciprocals, 6/7 versus 7/6. So are they perpendicular? Yes, they are perpendicular. And the last question. Line Q passes through the point 16, 8 and is perpendicular to the line y equals 1/2 x minus 5. When we see these words like parallel or perpendicular, you might want to highlight that so that you remember what type of slope you're looking for. Find the point of intersection of the 2 lines. Okay, so in order to find the point of intersection, I need to know the equations of both lines. So in this case, we need to start by finding the equation of line Q. We have a point on line Q, so that's our x sub 1, y sub 1. And I need a slope for line Q, and that comes from the fact that we know it's got to be perpendicular to y equals 1/2 x minus 5. Perpendicular, opposite reciprocal slope. So here the slope is positive 1/2. In our problem, we need the opposite, which means we're going to need a negative. Reciprocal of 1/2, 2. So our slope is -2. Okay, so let's deal with line Q. Y minus y sub 1 equals m times the quantity x minus x sub 1. Substitute in the values that we know. Y minus y sub 1 is 8 equals our slope -2 times the quantity x minus x sub 1, which is 16. Distribute and solve for y. Be careful when you distribute that -2 to the -16. It should change the sign. And then lastly, we're going to add that 8 to both sides to get y equals -2x plus 40. The point of intersection of two lines is the point where the one x value produces the same y value in both equations. So whatever value of x I would substitute in here to this equation that we just found for q. If I substitute a value in for x there, whatever y value I get as an output, whatever y answer I would get, would have to be the same as if I put the x into the original equation, y equals 1/2 x minus 5. I would have to get the same output from one x value. Now the way we determine that x value is by saying, well, if the y's have to be equal, then this expression from the equation for line Q and this expression from the original equation, if their y's have to be equal, then these two expressions have to be equal as well. So -2x plus 40 must equal 1/2 x minus 5. You get to use a little algebra and find your value of x. So I'm going to start by adding 2x to both sides. 2.5 x minus 5. Add 5 to both sides. And then divide 45 by 2.5. Now, if you've done that all correctly, you should end up with 18 for x. We need to substitute that into one of the two equations to determine what the y value is going to be. It doesn't matter which equation you put it back into. Whichever one you substitute it into should give you the same answer. If you want to check and make sure that you've solved everything correctly up until this point, then you take that 18 and you substitute it into line Q, and you substitute it into the other one and see if they give you the same value. So in this case, on Q, if I substitute in an 18 for x, I get an answer of 4. And you can type that into a calculator and see where I got that at. If I took the 1/2 x minus 5 and substitute it in place of x there, half of 18 is 9, and 9 minus 5 is 4. So they produce the same answer, which is what should happen. Now be very careful. We're finding a point of intersection, which means our answer should be a point. Remember what points look like. Coordinate points are in parentheses, x value listed first, y value listed second, with a comma in between. So here the point where these two lines intersect would be the point 18, 4. All right, that takes care of what you need to do for the equations of parallel and perpendicular line notes. You have a corresponding homework assignment from the book that went with this one, which you can find on Lumen. If you have any other questions, or if anything on this didn't make sense, you know where to find me. Before school, after school, during class, whatever. But ultimately, these are the notes that you need then for parallel and perpendicular lines.